Before we begin example C, is there anyone that needs a refresher course on how a standard deck of cards is set up? Yeah? How many cards are there? 52. All right, so we have 52 total. Does anybody know how the cards are broken down into what kinds of groups? Okay, it's called 4 suits. You got your clubs. You got your spades. You got your diamonds. And you got your hearts. So how many of each suit are there if you divide 52 by 4? 13. And those cards are numbered 2 to 10. There's also a jack, a queen, a king, and then there's the ace. These 3 cards, jack, queen, king, are known as face cards, not the ace. Sometimes students want to include the ace in the face cards, but that's not true because there's no person pictured on the ace. Ace is not a face card. It can be a 1, or it could be something higher than king, the card higher than a king. So let's move on and do the problem. What we're going to do is we're going to go back to the strategy of a tree diagram. To do this, you should have plenty of room to make one. We're drawing 3 cards. So there are going to be 3 simple events, drawing a card, drawing a card, drawing a card, 3 individual simple events that make up one giant compound event. Just trying to incorporate some of our terminology from this chapter. So on pick number 1, you could either get a heart or not a heart. So we're going to use heart and then N. Okay? You can either get a heart or not. You understand the difference in the 2 branches? Okay. Now, what is the probability of getting a heart? Let's go out of 52. There are 13 hearts out of 52. That's the probability of that branch. How many are not hearts? 39 out of 52. So that's the first pick of a card. You don't put it back and you pick another one. So we're going to make 4 more branches. 1 here, 2 there, and 2 there. So you could either get a heart, then another heart, or a heart, then not, or this compound, this series of events could have gone this way. Not a heart, heart, not a heart, not a heart. Does everybody understand why the second simple event has 4 branches total? Because it's made up of the 4 compound events, heart, 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 not, heart, not. That's why there are now 4 total branches to our tree diagram. Moving on. Put in the numbers that represent, on pick number 2, what's the probability you'll get another heart? It's not 13 out of 52 anymore, it's 12 out of 50. You took one, 51. There are only 12 hearts remaining because along this path, we assume we got a heart, so there are only 12 left. We got a heart, so there's only 12 left. We took a card, so there are only 51 total cards left. What fraction would go here? 39 out of 51. If you got a heart on the first pick, if you took a heart, how many non-hearts are still in there? Out of how many cards? There we go. 51. Okay. What would happen under the non and then heart? So 39 other cards. So how many hearts remain? Well, we didn't get one. Yeah, we didn't get one. 13 out of 51. 38 out of 51. Now we're going to draw the third series of branches that represent the third simple event, which is picking a third card. But how many total branches are there going to be if each of these 4 have 2 more? 8. We have 8 total paths. Heart, not. Heart, not. And so on. You could just use an H if you'd like. So now we need to figure out the fractions that represent each branch in these 8 paths. So we have to consider that we got a card and it was a heart. We got another card and it was a heart. So how many remain to get a third? 11 out of how many cards remain? 11 out of 50. That's going to disappear. 11 out of 50. Is that clear as to why it's 11 and why it's 50? On the third try, if you already got 2 hearts, there are only 11 left. If you took 2 of the 52 cards, there are only 50 left. Now, what about this N branch right here? We know that there are only 50 cards left. Of those 50, how many are not hearts? Still 39, because you got 2 hearts in the first 2 tries. So what happens here depends on what happened in the previous branch. So what we see today, as opposed to yesterday, is our first example of a dependent event, where these fractions depend on which original path you take. What I mean by that is, are these two fractions the same as these 2 fractions? 13 on top, 38 on top, 12 and 39. Are they different? They're different. That means these are dependent. The fractions we have here depend on what the first path was. They change if you go down the no heart path. Let's move on. So, let's see. Ready? Okay, let's do the branch right here. What's going to happen? You took one of the 13. You didn't get one of the hearts. How many hearts are left? 12 out of 50. All the denominators here are going to be 50 because you took 2 of the 52 cards. You got a heart. You took a non-heart. How many non-hearts are left? 38 out of 50. Bryn, can I ask you this? What do these 2 numerators always add up to? 50. Because these are the remaining hearts. These are the remaining non-hearts. They have to add up to the remaining cards. Okay, we're back and we completed the list. We completed the fractions that are on the tree diagram here, 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 and there. Check those to make sure you agree with them. Now it's time to pick out the paths that are favorable. What is the question asking? What's the probability of what? Exactly 2 hearts. So let's highlight the paths that apply. Is the topmost path favorable? Heart, heart, heart. No, we want how many? Exactly 2. So let's go ahead and do, we want heart, heart, not a heart. Is that a good path? So along the way, you multiply this times this times this. What do you get? Go ahead and multiply. That probability times that probability times that probability is, let's go to the nearest thousandth, which would be the nearest tenth of a percent. So it's 0.046, which is about 4.6%. We're not done. That's the probability you get heart, heart, and not heart in that order. Yes. So let's find another path. Not heart, heart, heart. So we have 39 out of 52 times 13 out of 51 times 12 out of 50. Do you again get 0.046? Does anybody know why? Corey? Yeah, same paths. And what's true about the numbers you're using in each case? For example, here, it's a 13 on top, 12, and 39, while this one's 39, 13, and 12. Same numbers, right? It's the same numbers in a different order. All right? The bottom has 52, 51, 50, 52, 51, 50. So for multiplying the same numbers on top and bottom, you're going to get the same answer. Is there another path that's favorable? Okay, heart. Oh. Not heart. Heart? Yes? Is that what you guys are saying? So let's multiply this times that. Same fractions, different order. What are we going to get? 0.046. Now, since we don't care about the order, our answer is this or that. So what do? You add them together, and you get a total probability of give me one more decimal, 0.12. Oh, sorry, 0.138. That makes sense. 0.138. So we have a 13.8% chance of getting 2 hearts out of 3 cards. All right?